Just as you walk down this promenade at the Undercliffe Cemetery, on your right hand side there's a vacant piece of land. And we're going to pose the question in this video, were there any burials from the past? Are there any remains? Because there's some doubt if there are any burials here. And this is going to be a kind of a 𝗕𝗂𝗂𝗍 episode of Bradford Through the Lens, because we're going to actually bring a department called Archaeological and Forensic Sciences from the Bradford University. And there'll be a bunch of students, and they'll bring their fancy gadgets and machines. You'll get to see all this on video, and you'll get to see them how they actually use it. And hopefully at the end of this video, we'll put a conclusion together and see whether they can detect any remains, skeleton remains, or even burials, or coffins, or shrouds. I don't know how these things work. But be warned, there'll be a lot of technical jargon. There'll be a lot of nerdy words, which I'm going to best try to, edit them in a certain way that we'll understand. So I know people into the history and the archaeological side of cemeteries are going to love this one. So thanks for watching.
So we are here today for teaching purposes actually, but it's also somehow helping out the Undercliffe Charity here. We will investigate some parcels of the cemetery in a search for burials. They don't know if there are any burials in the area, and what we are doing for teaching is forensic geophysics class. So we're demonstrating students how to apply near-surface geophysical methods for search of burials on unmarked graves or mass graves. So that's a sort of a cooperation that we have here.
Yeah. I find this quite fascinating because the channel does run on about Bradford history and heritage,
yeah.
And I think that's quite connected as well. You don't know what's under the ground.
Exactly.
Yeah.
So there is a bit of history, a bit of archaeology, a bit of forensic search here, and what we are famous for, which is the cutting-edge prospection methods. So Bradford, the University of Bradford, is a domain of archaeological prospection. And with our recent substantial funding for infrastructure, we will apply cutting-edge methodologies here, magnetic prospection, electrical prospection methods, as well as the GPR, ground-penetrating radar. And I hope those methods and our efforts here today will help the charity to find the graves in this beautiful setting full of history carved in stone, as they call it.
So just back of there you can see the students. Let's join them and let's see what happens.
One group is gonna start in the historical area, so we don't disturb each other. Some of the devices must not be close to other devices like the magnetometer, so there is no interference. So we will deploy three different methods, three sets of methods. So magnetic prospection with Bartington gradiometer, earth resistance survey with Geoscan Research RM85 meter, which is also Geoscan Research is a Bradford-based company, and a single channel GPR survey today with 𝗕𝗲𝗱 Ramak system with 400 MHz antenna. So that's the plan for today. And what can I say? Let's find some graves, or maybe let's not find any graves. But what would be the maximum depth, estimated depth of burials if you would expect them here?
Big grave. Because it's this area, and this would have had to have been dug, by shovel, so the maximum area depth would be 9 foot.
If it was used as temporary burial, Graham,
Pardon?
what we're worried about is that it might have been used for temporary burials, would be dug as deep.
So you've got to understand that all the people wanted to be over there, so this would have been the extremities.
Hi Ben, I've just noticed the students have their measuring tape out at this piece of land here. What are they actually doing?
So it's quite a preliminary step in just delineating out kind of the space that we're going to be working in, trying to appreciate how they're going to use the skills and techniques that we looked at previous weeks to try and develop their understanding about how they're going to survey this land that we're going to do today. So it's a pretty preliminary step, just getting them thinking about what they're going to do next.
Okay guys, so brief me, what have you found out about the area?
Hold on, I'll get the screenshot up. We measured 16.3 by 48.16 meters.
48, so this is this extent, yeah,
Yeah.
here. Okay.
And then we were thinking the next course of action would be to lay a grid.
Exactly.
Oh, that looks fascinating.
Yeah,
What's this called?
that's the single channel GPR, ground penetrating radar.
Right.
And it sends a radio pulses, so an electromagnetic wave into the ground.
Right.
Then it measures the time and the amount of energy that is reflected from the features underground. And with high resolution sampling, we're getting the information in 3 dimensions about the
Right.
subsurface structures.
My name's 𝗵𝗿𝗱𝗮. I'm a PhD student at University of Bradford, and I'm just demonstrating the Bartington 𝗕𝗿𝗄𝗲 fluxgate gradiometer, described as the workhorse and racehorse of modern archaeology, mainly because it's able to detect a very wide range of archaeological features, and it's really quick to operate. So it's one of the first techniques that we use, just because it's able to give us a broad overview of what's going on, and then we use the other techniques to really focus in, especially where we've got areas of interest. We then can follow up with the GPR equipment and the earth resistivity that you've probably already seen. So we've just got this set up for the 10-meter grids that Michael was establishing earlier.
So this kit is for electrical resistivity measurements. So we inject the current to the ground and we're measuring the value of resistivity. So here we are doing the single channel GPR survey. This is a 500 megahertz antenna that would give us the depth of prospection of about 4 meters maybe in these conditions, and it helps us to record any subsurface features that would have different properties from the surrounding soil. So this is earth resistance prospection. That frame over there, it contains 6 electrodes. Some of them inject the ground, some of them are measuring the resistivity of the given point, and that's how we can map the electrical resistivities of the subsurface, having the distribution of this property, and create the geoelectrical maps at different depths. And if there would be any graves or stones within the range of our prospection, we would certainly capture them. So this is electrical resistivity tomography. Along this array of 64 electrodes, we're injecting the current into the ground, creating like a geoelectrical cross section to see if there are any disturbances, any graves, any burials underneath. My students over there are collecting the 3D GPR data, and we're gonna see are there any burials. So we surveyed this whole area of your interest where you wanted us not to find any burials. And I'm quite satisfied to say that we're almost sure there are little to none graves in this area.
Okay.
I'm just gonna show you one of the profiles where we found the suspicious anomalies. So this is a slightly processed data. If I add the horizontal high pass, there you could see the amplification of the electromagnetic wave in this area as well as in this area. So there are 2 potential spots here where we could see something. You got some reflections over here.
Okay.
These are the existing graves.
Yeah, in this section, yeah.
I'm gonna show you this in GIS integrated with the satellite imagery to better show you where we are. but first let's analyze the data. You can see some individual burials here, so that's your row that goes along the curb here.
It is, yeah.
Then we go down. Got one reflection here that is very linear, very well defined, and something going on here as well. So these are the only two features that we really captured in this area.
Yep.
Mind you, they were like neighboring with the next row of
Yes,
graves
they were,
in
yeah.
this area. So it could be something like a collapsed grave,
Okay.
collapse in that direction. It's not necessarily another burial here. However, it's not, you know, impossible, because we can see some reflection, we can define its depth. So they both they appear at like 1m20, 1m40, and that one continues quite deep, up to 2 meters, where it gets stronger. But this might be related to bedrock, just like this area here, because it's vast in general and pretty amorphous, while those ones are better defined. So two only spots that you should
Avoid.
you know, avoid or check or just be careful when exploring. But the rest of the plot, I'm happy to say it's
free
pretty
for,
free
for plots.
Yep.
And these anomalies as well, so they're about a grave length, aren't they? In
I would say so. Yes, we can
With-
check that in GIS in a moment, but it looks like it would be about 2 meters.
Okay.
I can switch on the swaths here. So the width of this is like 60 centimeters. So if you would take three of them,
yeah, so it's
that
about,
would make it
about 2 meters.
152 meters probably.
Yeah.
Discussing the results starting from the mag. So magnetometry didn't, as expected, didn't bring a lot of information. Basically what you can see here is the noise from scattered metal objects, ferrous objects. So it's not very informative. We just found the contamination, but I think that you're aware of the presence of some different materials. They're like stones, bricks, and ferrous metal features. So that's quite clear. Then we have earth resistance data. I'll switch of the mag. And earth resistance data is much less accurate, maybe not accurate, but the resolution is much lower than the 3D GPR survey. However, it's coherent with the GPR results that I've shown you.
Yeah.
So we've got this area of higher electrical resistivity in this part, and something going on here, and that's the most shallow level because we got like 3 depth scans, we could say. Of course, the GPR data overlaid. This is the resolution of like 6 by 6 centimeters, and we're talking about the precision of this georeferencing within like 3 centimeters. So it's very accurate. You can see the row of existing graves, those anomalies here. And the only 2 spots that you need to be aware of. Otherwise, all of that looks pretty clear.
Yeah, which is great news.
Yeah.